Hey everyone, and welcome. Today, we're jumping into the awesome world of single-board computers. Now, for years, one name has pretty much owned this space, Raspberry Pi. But lately, with prices going through the roof and stock just vanishing, you have to ask the question, is it finally time to look for an alternative?
Man, this quote hits home, doesn't it? If you're in the maker community, you know exactly what this feels like. Those days of just grabbing a cheap, super capable board for a fun weekend project, well, they feel like they're a million miles away. And that's really the problem we're going to dig into. The Pi just isn't that easy, budget-friendly go-to that it used to be.
And here's the reality of it. The newest Raspberry Pi 5 can easily cost you $80, or even more. And that's a big if you can even get your hands on one. That price tag really pushes it out of that, oh, I'll just grab one category, and makes it a much more serious purchase. And that, right there, changes the entire game for hobbyists.
So yeah, that brings us to what a lot of people are calling the Raspberry Pi problem. It's really this perfect storm, right? You've got insane demand from everyone, hobbyists, industrial users, you name it. Then you add in all the supply chain headaches we've had, and what do you get? Much, much higher prices. And for the makers and developers who really built this community up, that's a huge challenge.
But, every challenge really does create an opportunity. The sort of vacuum left by the Pi's scarcity has sparked this amazing wave of new, incredibly powerful, and this is the best part, available alternatives. The Pi's grip on the market is definitely being challenged, and honestly, the world of single-board computers has never been more exciting.
So, what are the real reasons to venture beyond the Raspberry Pi? I mean, what are these other boards actually bringing to the table that's so special? Let's break it down.
The advantages are pretty hard to ignore. First off, we're talking about boards with way more raw CPU and GPU power. They often pack unique hardware features you just won't find on a Pi, like an NPU, a neural processing unit, which is basically a little brain just for AI tasks, or native SATA ports, which are perfect for building a proper home server. All this usually adds up to a much better price-to-performance ratio. And of course, maybe the biggest win of all, you can actually buy them right now.
And hey, this isn't just something happening in basements and garages. This chart shows a really clear trend. Academics and professional researchers are using a wider variety of these boards. It's proof that developers are actively looking for more powerful platforms for everything from IoT to complex data crunching, moving way beyond the old standards.
All right, it's time to meet the competition. We're going to look at a few different types of boards that are giving the Raspberry Pi a serious run for its money, and each one has its own special superpower.
First up, for anyone out there who just craves raw, unfiltered power, meet the Orange Pi 5 Plus. This thing is an absolute beast, built for the toughest jobs you could possibly imagine for a tiny computer like this.
Okay, just take a second and soak in these specs. An 8-core CPU, up to 16 gigs of RAM, and support for super-fast M.2 NVMe storage. But the real showstoppers here are the NPU, which is rated at 6 TOPS, that's trillions of operations per second for AI, and the fact that it can handle 8K video. That's just wild.
So what does all that tech speak mean for you? Well, this board is absolutely perfect for on-device AI projects, building a monster 8K media server, or hosting your own local services. And to put that performance into perspective, get this. Compiling the entire Linux kernel takes just 12 minutes on this thing. A Raspberry Pi 4, that'll take you 33 minutes. That's not just a little faster, that's a completely different league.
Okay, now let's do a complete 180 and swing to the other end of the spectrum. If your main goal is getting the absolute most bang for your buck, you've got to meet the Libre computer AML's 95XCC, which has the amazing nickname Lee Potato.
For right around that original, classic Raspberry Pi price, you get a really capable quad-core processor, and, this is the key, hardware-accelerated 4K video playback at a smooth 60 frames per second. It's not trying to be a performance monster, it's just really, really good at what it's designed to do.
So who is this for? Well, it is the perfect board for a simple media center running something like Kodi or Plex. It's a fantastic option for classrooms or for anyone wanting to build a small computer cluster without breaking the bank. Basically, if you've got a project where an old Pi 3B Plus is almost powerful enough, Lee Potato is your perfect, affordable upgrade.
Okay, so we've looked at a powerhouse and a budget king. But that brings us to the really important question. How much performance are you actually getting for every dollar you spend?
Wow, this chart really tells the whole story, doesn't it? What we're looking at here is the Geekbench score divided by the price, a simple value score. The Raspberry Pi 4 clocks in at a score of 13. Lee Potato is better, at 18. But then look at the Orange Pi 5B, a score of 54. It's crystal clear from this chart. These alternatives are offering so much more raw power for every single dollar you spend.
All right, for our final contender, we're stepping into a completely different universe. What if your project needs more than what a normal single-board computer can give you? What if what you really need is the power and flexibility of a real compact desktop PC? For that, there's the Odoo Bolt V8.
I mean, this board is just in a different league entirely. It's built around an AMD Ryzen processor with powerful Radeon Vega 8 graphics built right in. You can load this thing up with 32 gigabytes of actual desktop RAM. But the most important part is its x86 architecture. That's the same kind of processor you'd find in a desktop or laptop. And what that means is it can run the full version of Windows or any Linux desktop you want.
This just blows the doors wide open on what's possible. You could literally use this as your main desktop computer. You can do video editing, 3D modeling, run multiple virtual machines at once. It completely blurs the line between a hobbyist single-board computer and a genuinely powerful, compact workstation.
Okay, so we've seen a ton of amazing options, but with all this choice, how on earth do you pick the right one for you? In this last section, we'll break it down into a super simple framework.
It really just comes down to 3 easy steps. First, define your project. What is it exactly that you're trying to build? Second, set your budget. How much are you actually willing to spend? And third, and this one is so important, check the community and the software support. A super powerful board is totally useless if the software is unstable or there's nobody online to help you when you get stuck.
And to make it even easier for you, here are some direct recommendations. If you're building a media center, the Lee Potato is a fantastic budget choice. Building a home NAS for your files? Look for a board with native SATA ports, like the Radsat Rock 3A. If you're diving into AI, the NPU on the Orange Pi 5 is a perfect fit. And if you want a true desktop replacement, it has to be one of these powerful x86 boards, like the Odoo Bolt.
So here's the big takeaway from all this. The Raspberry Pi's monopoly is over. The golden age of single-board computers is happening right now, and it is full of incredibly powerful, affordable, and available choices. You don't have to default to a Pi anymore. You can, and you should, match the board to your mission. So that just leaves one final question for you to think about. Which one of these amazing boards is the right fit for your next build?